the third step is to add two partial equations, no? I-add na to ang duha ka half reactions and then cancel all electrons involved in the reaction. So this is our oxidation reaction, which is balanced already in terms of the number of atoms and in terms of the charge, they are balanced already. And this is also our balanced reduction reaction. Okay, so here we cannot cancel out electrons yet because on the oxidation number, 1 electron ang nadugang. Sa reduction reaction, 2 electrons. So di nato ma-balance. So in order to balance, i-multiply nato ang atong oxidation reaction by 2. So by multiplying by 2, it becomes, okay. So we have 2 moles of iron 2 ion. Then sa product side, we have 2 moles of iron 3 ion plus 2 electrons. And then just rewrite the reduction reaction. Okay. This time, pareho na ang atong number of electrons added. So we can cancel them out. Okay. And then you write what is left. So we have 2 moles of iron plus 2 or iron 2 ion plus bromine molecule to yield 2 moles of iron 3 ion plus 2 moles of bromide ion. Okay, so let us see if our equation is balanced. So in terms of the number of atoms, this is 2 times 1 equals 2. For bromine, on the product side, 2 times 1, 2. So balance ang atong iron. For bromine, this is 1 times 2 equals 2. This is 2 times 1 equals 2. So balance with respect to the number of atoms. Now, with respect to charges, let us see kung balance na ba. This is 2 times positive 2. That is positive 4. Then this is 1 times 0 equals 0. 2 times positive 3 equals positive 6. Okay. Then 2 times negative 1 is negative 2. Positive 6 and negative 2 is positive 4. So they are balanced. Okay. Do you understand?
Yes.
Sige. Sulat na ako. Okay. Now, if the redox reaction is in acidic solution, sa may mahitabo kung nasa acidic solution ang ato ang redox reaction. So the same lagi hapon, step 1 is to write and classify the half reactions. So before we can classify them, we need to determine the oxidation number of each element. So our manganese here is positive 7. Our chromium is, no, this is not chromium, but carbon, which is positive 3. Then carbon here on the product side is positive 4. Okay. So oxygen atoms here are not peroxide, no? So oxygen in permanganate is negative 2. Oxygen in oxalate is also negative 2. And oxygen in carbon dioxide is negative 2. Okay. So the one that gives off, okay, tanaw na to ha, nganong si oxalate, nganong ang carbon ni oxalate ang nag-undergo og oxidation. It's because from positive 3 to positive 4 ang iyang oxidation number. So meaning, may give siya or may lose siya og it gives how many electrons? How many electrons does it give? 1. Okay, gives 1 electron. Okay. Now for manganese, from positive 7 to positive 2. So kung tanaw nato, nagamay ang iyang charge from positive 7 to negative to positive 2. So, nga naman kang nagamay ang iyang charge.
Nag-gain siya electron.
Nag-gain siyang electron. So, pila ang iyang gi-gain?
5.
Okay, so it gains
5.
5 electrons. No? Okay, so 5 electrons of positive 7, of course, ang nabilin is positive 2. So, meaning, kining 7 man ang protons niya. Naparisan og 5 ka electrons. So, ang naay duha nga walay paris, mana positive 2. So, the carbon in oxalate ion gives 1 electron. So, it undergoes oxidation. And manganese in permanganate undergoes reduction by gaining 5 electrons. It becomes positive 2. Okay. Okay. So, step 1, nahuman na nato ang step 1. We write already and classify the two half reactions, no? Nanatay oxidation reaction, and we also have the reduction reaction. Now, step 2. Wait, okay, balance with respect to atoms. So, we can balance the number of atoms by balance elements other than oxygen and hydrogen. So, ang una natong buhaton is to balance the other elements first, no? Other than oxygen and hydrogen. Then, after balancing the other elements, balance oxygen by adding water and balance hydrogen by adding hydrogen ion. Okay? So, ang buto sa bot, kung naay laing elements aside from oxygen and hydrogen, mo'y unahon na to balance. Like, sa pikas na ay carbon. Sa left side na ay carbon, sa right side na ay carbon. So, si carbon mo'y unahon na to og balance. Once carbon is balanced, i-balance na to si oxygen by adding water. Okay? And when oxygen is already balanced, i-balance na po nato si hydrogen by adding hydrogen ion. Okay? So, for our oxidation reaction, naatay how many atoms of carbon on the reactant side? There are 2. No? There are 2 atoms here. Dire, pila ka atoms of carbon?
1.
1. So, dili balance, no? So, to balance, pila man kaya ito ibutang dire para mabalance si carbon?
2.
Okay. We're going to put a coefficient 2 here. So, this time, carbon atoms balance na. No? 2 atoms of carbon, 2 atoms of carbon. Okay. Then, ang giingon, balance oxygen. Next is to balance oxygen. How? By adding water. Sige. Now, let us see first kung mabalance na natin si oxygen, ani, no need to add water. But kung dili nato mabalance si oxygen, that's the time for us to add water. So in this case, how many atoms of oxygen on the left side?
4.
1 times 4, that's 4. Oxygen on the right side, 2 times 2 is 4. So no need to add water. Okay, they're already balanced. Okay. How about manganese? Dere, how many atoms of manganese? Sa left side, 1. Sa right side, there is 1 also. So balance na si manganese. Now let us balance oxygen. What are we going to do? Pila may atoms of oxygen?
4.
How many atoms of oxygen are there? Okay, there are 4 atoms of oxygen. On the right side, there is no atom of oxygen. Pero giingon nga, balance oxygen by adding water. Okay. So we're going to add water here. How many moles of water are we going to add?
2 moles.
If we're going to add 2 moles,
4 di ay.
Nganong 4 man?
2 ma'am. Para na ay 4 oxygen atoms.
Okay. Yes, kay kung one molecule or in 1 mole of water, isa ra pud na ka oxygen atom. So kung 2 molecules of water or 2 moles of water ang atong i-add, duha ra pud ka oxygen atoms, still not balanced, no? So we are going to add 4 moles of 4 moles or 4 molecules of water. Okay? Okay, in these 4 molecules of water, pila ka atoms sa oxygen? This is 4 times 1 equals 4. So balance na diri sa pikas. 1 times 4 equals 4. Okay? Now, our manganese is already balanced. Our oxygen is also balanced. Pero, natay hydrogen nga nadugang. But giingon diri, we can balance hydrogen by adding hydrogen ion. So how many ions of hydrogen are we going to add?
8.
8. Why 8?
Because in the product side we have 8 ion hydrogen atoms, so therefore we have to add on the reactant side with 8 also to balance.
Exactly, no? Exactly. We're going to add 8 atoms. Okay, this is 4 times 2. So that's 8 atoms of hydrogen on the product side. So we're going to add 8 atoms, 8 moles of hydrogen. So in what side of the reaction are we going to add hydrogen ions?
In the reactant side.
Reactant side. Okay, so we're going to add 8 moles of hydrogen ion, no? 8 moles of hydrogen ion. So in this is 8 moles of hydrogen ion. This is also 8. Okay, 4 moles times 2, that's 8. Okay. By the way, do not be confused with moles, with atoms, molecule, no? Usay mo na kalibugan sa uban, no? So, para safe ta, pwede ta maiyon nga 8 moles. Kini 1 mole. 1 mole, 4 moles. Okay? Pero kaganina, nag-iyon lang po kog 4 molecules of water because water is a molecule. So it's also safe to say 4 molecules of water. Pero kini, kung may tag 1 molecule of manganese, manganese ion is not a molecule. So you better say 1 mole of manganese ion. Okay? Sige. So balance na ang ato ang oxidation reaction and reduction reaction with respect to the number of atoms. Step 3 is to balance electrically by adding electrons. So we'll start with our oxidation reaction. Okay. Now, tanaw nato kung balance ba ang ato ang oxidation reaction. So what is the charge of oxalate? This is oxalate ion. What is the
Negative
charge?
2.
Okay,
Negative
1 times -2, this is -2. On the product side, this one is 0. This is a molecule, no? The charge of the molecule is 0. So 2 times 0 is 0. So remember, we can balance the charge, we can balance electrically by adding electrons. So where will we add electrons?
Product.
On the product side or reactant side?
Product side.
Okay, product side. How many electrons are we going to add?
2.
2 electrons. Okay. So we have 2 electrons. No? So this time, the oxidation reaction is already balanced. For our reduction reaction, pila man ang charge ani per manganese?
-1.
-1. Here,
Positive 2.
Positive 2.
2. Oh. So, where will we add electrons?
On the reactant side.
How many electrons are we going to add on the reactant side?
Pila po?
Product
Pila
side.
man?
On the more positive side, you're going to add
4.
electrons on the more positive side. So that would be on the product side po.
Sige, kinsa tong nag-ingon nga diri sa reactant side, pila ka electrons atong i-add diri? Diri ba ta mag-add og electrons? If we will
No,
add
ma'am.
electrons here, the more it becomes
It will become negative po.
okay, negative. The more siya mahimong negative, so dili gyapon mo balance.
Oo.
So we're going to add electrons on
On
the
the more positive
Product.
side po.
product side. How many electrons are we going to add?
1 electron.
Okay, 1 electron. So by adding 1 electron, wait. Nato na-appeal og sulat kay dapat i-appeal na natong sulat si water, no? Og si hydrogen. Okay. Sorry.
Okay.
Naulahi og sulat. Sorry. So this is okay, before we
Reactant side.
can say that it is not balanced, atos ang tan-awon pila ang charge nila. Total charge sa reactant and total charge on the product. So this is positive 8. This is negative 1. No? So overall charge is positive 7.
7.
Okay, so here, this is positive 2, and this is 0. So the overall charge is positive 2. Okay, so asa man ta magdugang og electrons?
Reactant side na po. More positive.
Yes, correct. And how many electrons are we going to add?
5 electrons po.
5 electrons. So by adding 5 electrons, sige. Oh, by the way, basig ang uban got na confused, no? Kindly on. Okay, by adding 5 electrons, on the left side of the reaction, wait. By adding 5 electrons on the reactant side, so we have 5, negative 5. This is positive 8. This is negative 1. So pila ang total charge nila? This is positive
2.
Okay. Kini positive 2. This is 0. So the overall charge is positive 2.
Positive 2.
So it is already balanced electrically, no? Balanced electrically. Now the next step is to cancel the electrons. But again, we cannot cancel the electrons kay kini 5 electrons. Ang atong oxidation reaction, 2 electrons. So we are going to multiply. Okay? Unsa may common nila? Unsay common aning 2 ug 5? We are going to multiply,
Multiply.
no? Mag-multiply
The
ta ani ato
reaction
oxidation
by
number nga mo equal siya diri,
Yeah.
no? So para mo equal sila, pwede pod mag-multiply ta diri sa ato ang oxidation reaction of 5. By multiplying our oxidation reaction by 5, ang atong electrons mahimong 10. So kini ato pud ni siyang himuong 10 by multiplying this by 2. Okay. No? Okay. So by multiplying 5 to our oxidation reaction becomes 5 moles of oxalate ion, 10 moles of carbon dioxide, and 10 moles of electrons. Our reduction reaction becomes 10 moles of 10 electrons plus 16 moles of hydrogen. Tama ba? Kay 8 times 2, that's 16. Plus 2 moles of permanganate. Then we have 2 moles of manganese 2 ion and 8 moles of water. Okay, this time we can cancel out our electrons. So cancel. After canceling our electrons, sa may atong sunod buhaton, atong i-add ang duha ka reactions, no? Our 2 half reactions. So we have 5 moles of oxalate ion plus 16 moles of hydrogen ion plus 2 moles of permanganate ion. Then on the product side, we have 10 moles of carbon dioxide, 2 moles of manganese 2 ion, and 8 moles of water. Now let us see if our equation is balanced with respect to the number of atoms. Our carbon on the reactant side is 10, sa product side 10. Our oxygen, this is 5 times 4, is 20 plus 8. So that's 28. Here, 10 times 2, 20 plus 8, 28. So balance atong oxygen. 16 ang atong hydrogen. Here, 8 times 2, that's 16. Manganese is 2. Manganese is 2. So balance with respect to the number of atoms. How about the charge? For the charge, this is 5 times 2 equals negative 10. Wait. That lang, ha? So, i-erase. Para di ta maglibog. So, this is negative 10. And then, positive 16. This is negative 2. So, what is the overall charge of the reactants? Sila man eh. Negative 10, positive 16, and negative 2. What is the overall charge?
Positive 4.
Positive 4. Okay. Here, this is 0. This is positive 4 and 0. Okay. So, with respect to the number of, with respect to the charge, they are already balanced. With respect to the number of atoms, the equation is also balanced. So this is how to balance redox reaction in acidic medium. How about in basic medium? Okay. If the redox reaction is in basic medium, there is only a slight difference, no? Slight difference in balancing redox reaction between in acidic and basic medium. So if it is in basic medium, still we have to write and classify the half reactions. Like here, we have permanganate and sulfite ion. Then sa our reactants, our products, we have this is manganese 4 oxide and sulfate ion. Okay. So pila man ka ang charge sa ato ang manganese in permanganate ion?
Negative 1.
Negative
1.
Okay, tanaw na to. Negative 1 ba? Si manganese, it's positive 7. Ganong positive 7? Kay oxygen is negative 2 times 4 atoms, so negative 8. Inig-transpose, negative, may mo siyang positive. Positive 8 o negative 1, the overall charge, o na nga positive 7. Okay? How about sulfur here? Pila man ang atong charge sa sulfur?
4 plus.
Positive 4.
Okay, positive 4, no? Okay. The charge, the oxidation state of oxygen is negative 2 times 3, so negative 6. Pag transpose na to, mahima siyang positive 6. Positive 6 of negative 2, that's positive 4. Okay. Here, sa man ang charge
4
sa,
plus.
ha?
4 plus po. Positive 4.
Okay, correct. Positive 4. Ang atong sulfur dire, sa product side.
6 plus. 6
Okay,
plus
correct.
po.
Yes. And oxygen atoms, oxygen atom here is neither reduced nor oxidized. Okay. So which element undergoes oxidation?
Is
Oxidation is sulfur po.
oxidation.
Sulfur po.
Sulfur?
Yes po.
Okay. Yes, correct. Ilaman, how many electrons?
2.
So kung nag-oxidize siya, it loses electrons.
2 electrons po.
Electrons are lost. two electrons, no? By losing 2 electrons, the more siya nahimong positive, mo na nahimo siyang positive 6. Okay, so sulfur in sulfite ion undergoes oxidation, and si manganese, does it gain or lose electron?
Reduction.
Gain electron.
Nag-gain siya. So siya ang nag-undergo og reduction. How many electrons does manganese gain?
Three.
Three.
Three electrons.
Okay, 3 electrons. Correct. Okay, so sulfur in sulfite ion undergoes oxidation, and manganese in permanganate ion undergoes reduction. Okay, next, balance elements other than oxygen and hydrogen. Then balance oxygen with water. Sunod is to neutralize hydrogen by adding hydroxide ion on both sides of the reaction. Okay, so we'll start with the oxidation, the one that undergoes oxidation reaction. So balance na bang atong sulfur? Is sulfur atom balanced already?
Yes.
Yes, no?
ma'am.
1 atom of sulfur. Okay, so balance na. Now let's proceed to oxygen. Balance oxygen with water by adding water. So kini 3 atoms of oxygen, this one 4 atoms of oxygen. So where will we add water? Left side or right side? Ha? Asa
On
to
the
mag-add Dan?
diffusion.
Sir Dan, where will we add water? Left or right side? Ha? Sa left. Okay. How many molecules of water are we going to add? Okay, 1, no? By adding 1 molecule of water, na-balance ang atong oxygen, pero ang atong hydrogen is not balanced. So, giingan diri, neutralize hydrogen by adding hydroxide on both sides of the equation. Okay. So,
This
to balance hydrogen, let us balance first hydrogen. Kaya na may 2 atoms of hydrogen on the left side. So we're going to add 2 moles also of hydrogen ion on the right side. Then after that, we need to add hydroxide ions on both sides of the reaction. So okay. So it becomes like that. No? Okay, so balance na with respect to atoms. No? Na-balance na ba with respect to atoms?
Yes po.
Okay. Then for our reduction reaction, manganese is already balanced. Oxygen is not balanced. So where will we add water? Left side or right side?
Right side.
How many moles of water are we going to add? 2 moles of water. Okay. And then neutralize. Since we are adding water, na nadugang hydrogen. So we're going to add also hydrogen ion on the left side. We're going to add 4 moles of hydrogen ion. And then to neutralize, add hydroxide ion. So since there are 4 moles of hydrogen ion added, we are going to add 4 moles of hydroxide ion on both sides. No? So this time, our reduction reaction is also balanced. Okay, then step 3 is to balance electrically by adding electrons. Okay, so this is our reduction reaction. And the charge here is -2. This is 0, -2. So pilang overall charge? This is -4. This one is -2, +2, -2. So the overall charge is -2. So where will we add electrons? Left side or right side?
Right side.
How many
Right side.
electrons are we going to add?
2.
2.
2. Okay, we're going to add 2 electrons on the right side. No? Sige. Saan i-erase? Then for our reduction reaction, this is -4, +4, -1, 0, 0, plus -4. So the overall charge here is -1. Dari, -4. So where will we add electrons?
Left.
Left. Okay, how many electrons are we going to add? Pila ka electrons atong idugang sa left?
3.
Correct.
3.
Yes, 3. No? Okay. So, after this, dili man sila the same. So, we're going to multiply this by what number? Pila itong i-multiply? Aning atong oxidation reaction?
3.
2?
3.
3. Okay. So, multiply our oxidation reaction by 3. Then, multiply our reduction reaction by 2.
2.
No? So, our oxidation reaction becomes 6 moles of hydrogen ion plus 3 moles of water plus 3 moles of sulfite ion. Then sa reactant side, 3 moles of sulfate ion, 6 moles of hydrogen, 6 moles of hydroxide, and 6 atoms of electrons. For our reduction reaction, okay, we have 6 electrons, 8 moles of hydroxide ion, 8 moles of hydrogen ion, 2 moles of permanganate ion, 2 moles of manganese 4 oxide, 4 moles of water, and 8 moles of hydroxide ion. Okay, then cancel our electrons. No? Okay, cancel our electrons. And then we're going to add our 2 half reactions before we cancel other molecule. Baka tayo pwede makancel, but para di ta maglibog, we need to add them or combine our 2 half reactions first. Okay, so we have 6 moles of hydroxide ion, 3 moles of water, 3 moles of sulfite ion. Then, we have 8 moles of hydroxide, 8 moles of hydrogen, and 2 moles of manganese 4, 2 moles of permanganate ion. Then, sa product side nato, 3 moles of sulfate ion, 6 moles of hydroxide ion, 6 moles of hydrogen ion, 2 moles of, what's this? Manganese 4 oxide, 4 moles water, and 8 moles of hydroxide ion. Okay, na ba tayo pwede makancel?
Yes po.
Okay,
Na.
pwede na ito makancel si hydroxide.
Hydroxide ion.
Oh, so this is 6, this is 8. So kung ato na i-cancel, mahimo na lang ni siyang 2. Okay, pero giuna din nato ni si water. Kung ato i-combine ang 8 moles of hydroxide ion ang 8 moles of hydrogen ion, it forms 8 moles of water. Atong i-combine po ni 6 moles of hydrogen ion and 6 moles of hydroxide ion, it will form 6 moles of water. So 6 moles of water and 8 moles of water. So ang mabilin dire is 2 moles of water. Diba? Then napailain. Okay, si hydroxide, there is 6 moles of hydroxide ion, dinhi 8 moles. So pila ilang difference? 2. So on the right side, na nabilin 2 moles of hydroxide ion. Then there's another molecules of water. On the left side, 3 moles, there is 4 moles. So pwede gihapon nato na sila makancel. Pag-cancel nato, wala ko na appear. Okay, cancel. So na mabilin dire nga 1 mole of water. Okay. Now, 1 mole of water, kunya kini 2 moles of water, so makancel na siya. Ang mabilin dire is 1 mole of water. So, 1 mole of water, then write what is left. Say nabilin dire sa reactant side, 3 moles of sulfite ion, 2 moles of permanganate ion. Sa product side, we have 3 moles of sulfate ion, 2 moles of manganese 4 oxide, and 2 moles of hydroxide ion. Okay? So let us see kung balance na ba ang with respect to number of atoms. With respect to the number of atoms, there are 2 atoms of hydrogen, 2 atoms hydrogen. Oxygen, this is 1 plus 9, 10, plus 8, 18. This is 12, plus 4, 16, 17, 18. So balance ang oxygen. Manganese is 2. Sulfur, this is 3, 3. Manganese, 2, 2. So balance na ang number of atoms. Then for the charge, this is 0. This is -6. This is -2. So the overall charge is -8. Here we have -6, 0. This one is -2. The overall charge is -8. So it is already balanced with respect to the number of atoms of each element, and it is also balanced electrically. So this is now our balanced redox reactions. Do you understand? Hello?
Yes, ma'am.
Yes po.
Okay. So if there are no questions, let's continue. Wait, okay, there are types of redox reaction. So we have the combination reaction, and it takes this format. A plus B yields C. Okay, for example, 2 moles of aluminum plus 3 moles of bromine molecule to yield 2 moles of aluminum bromide. Okay, why is this a redox reaction? Because one element is oxidized, the other element is reduced. So kinsa man kaani ang nag-oxidize? Okay, aluminum here is, the charge of oxidation state of aluminum here is 0, and for bromine, it's 0 also. Diba? Kaya they are in the uncombined state pa. Pag abot sa product, aluminum is +3, bromine is -1. Okay? So kinsa may nag-oxidize kaani?
It's aluminum.
Aluminum oxidizes and bromine is reduced. Okay. Another type, another type of oxidation reaction is the decomposition reaction, and it takes this format: C yields A plus B. So for example, the decomposition of this is potassium chlorate. Potassium here is +1, chlorine is +5, oxygen is -2. On the product side, potassium is +1, chlorine -1, oxygen is -2. Oxygen is 0 because it is in the uncombined state. So which reduces and which oxidizes? Kinsa may nag-oxidize?
Chlorine reduces.
Si chlorine. Okay, chlorine reduces. Okay,
And oxygen,
chlorine ba nag-oxidize? Chlorine ba
Ang
nag-reduce?
ang chlorine ang na-oxidize and ang oxygen ang na-reduce.
Si chlorine ang nag-oxidize. Ato pa siya ang nag-undergo oxidation. So kung nag-undergo oxidation, nag-lose og electron. Nag-lose bag electron si chlorine?
No, it's oxygen that loses electron, ma'am. Because from -2, it becomes closer to positive man, so 0. So as the number
So?
of oxidation state increases numerically, so 1 siya, oxidation po. Nag-loss.
Okay. So it is the
oxygen
electron
po
that
ang
loses electron, no?
Yes po.
It is oxygen that loses electron. How many
Yes po.
electrons does it lose?
2 electrons po.
Okay, so nag-lose siya 2 electrons, no? So it gives 2 electrons. By giving 2 electrons, imbis kay milabaw iyang electron og duha, iya mang gihatag ning labaw niya nga electron, mo na nahima siyang 0. 0 meaning equal ng iyang protons and electrons. So its charge is 0. Do you understand? Si chlorine, from positive 5 to negative 1.
So gain po.
Oh, sa ato pa may gain siya. Pila man ka ang iyang gigain?
That's 5 electrons pa. 4.
5. Kung 4, kung
Four.
4 iyang electrons nga gigain,
5.
labo positive 1 unta ni. Kung 5 pud ni, if this is 5, nya positive 5 ug negative 5, 0 unta ni. So pila man ka iyang gigain? Pila
4.
iyang gigain?
4.
Kung 4 electrons iyang gigain, dapat this is positive 1.
No?
Positive 1 unta na, no? Pila ka ha?
So yung 5 minus
This must
1.
be, imigain siya og, dapat may gain siya og
6.
6 electrons. Correct. Okay, may gain siya og 6 electrons. No? So by gaining
po,
6
yes po.
electrons, so 6, negative 6 og positive 5 mo na nahimong negative 1. Do you understand?
Yes po. Yes po.
Okay. So it is oxygen, it is the oxygen in potassium chlorate that gives oxidizes by giving 2 electrons, and it is chlorine that reduces by gaining 6 electrons. Okay, so this is decomposition reaction, but it is a redox type of reaction because one atom or one molecule is, no, not one molecule, but one element oxidizes and the other element reduces. So it is reduction reaction, redox reaction, sorry. Okay. Okay, then we also have another type of reaction is combustion reaction. That is if an element reacts with oxygen, no, to form a new compound. For example, sulfur reacts with oxygen gas to form sulfur dioxide. Okay, so here sulfur is in the uncombined state, so its oxidation state is 0. Oxygen also is 0. Now, pila man ka ang sulfur, ang oxidation state diri sa oxygen o sa sulfur on the product side? Pila si oxygen sa product
Oxygen.
side?
Oxygen product side ma'am is -2.
So minus.
Sulfur
Okay.
is 4.
Sulfur is
4.
positive 4. Okay, correct. So which reduces and which oxidizes?
Oxidizes sulfur, reduces oxygen.
So oxidizes daw, the one that oxidizes is sulfur. Is it correct? Tama ba?
Because it gives off
Okay, it gives off how many electrons?
4.
4. So by giving
Four.
off 4 electrons, sulfur becomes positive 4. Kaya milabaw na din iyang protons of 4. Then si oxygen may nag-undergo og reduction because it gains 2 electrons from being 0, imbis kay equal iyang proton and electron here, hindawat man siya duha ka electron, so it becomes negative. Okay. Then another example, we have magnesium reacts with oxygen to form magnesium oxide. Oxygen here is 0. Magnesium also is 0, but on the product side, magnesium is positive 2, oxygen is negative 2. Now, which oxidizes and which reduces?
this electron ma'am, so it oxidizes.
Huh?
And oxygen.
Isn't it
Magnesium.
oxidize? Magnesium?
Magnesium.
Yes, correct. Magnesium
And then
oxidizes.
oxygen
And oxygen reduces. Correct. No? Okay. Now, another type is the displacement reaction. Okay, it takes this format A plus BC to produce AC plus B. Okay, for example, strontium plus 1 mole of strontium plus 2 moles of water to produce 1 mole of strontium hydroxide and 1 mole of water. Okay, what is the oxidation state of strontium here?
Zero.
Okay,
Two.
strontium here is 0. Then
Oh.
oxygen here is -2. So si hydrogen +1. Okay, di ba? Kung si hydrogen mo bond og non-metal, si hydrogen is positive. But if it bonds with a metal, hydrogen is negative. Okay? Then strontium on the product side is +2. No? Oxygen is -2. Hydrogen here. Okay. Pero, wala na lang kaayo. Pag-abot diri si hydrogen, this is the whole hydroxide ion is -1. Muna si strontium is +2. Pag abot diri hydrogen is 0. No? Kay it is in the uncombined state. Now, this type of displacement reaction is hydrogen displacement. Nga naman, hydrogen is being displaced after strontium reacts with water. So this is hydrogen displacement. Now, which undergoes reduction and which undergoes oxidation? Which oxidizes and which reduces?
Hydrogen. Strontium oxidizes and hydrogen.
Strontium oxidizes. Okay, nag-lose ba siya electrons?
Wala.
Si strontium, nag-lose bag electron si strontium from 0 ang iyang kuan, meaning equal ang iyang proton og electron. Pag abot diri milabaw na iyang proton. So unsa man kay gimin ano?
Nag-lose.
Okay, it loses electron. Pila ka electrons iyang gi-lose?
2.
2, correct. How about hydrogen? So kung
Nag-
nag-lose si strontium, sa ato pa nag-gain si hydrogen.
Hydrogen.
Pila man iyang gi-gain?
1.
1 electron. Okay, very good. Okay, another displacement reaction is a metal displacement reaction, no? Like titanium 4 chloride reacts with magnesium. Pulihan ni magnesium si titanium, no? Releasing titanium and magnesium chloride. So titanium here, which is a metal, is being displaced. So we call this displacement reaction as metal displacement. Okay, pila man si titanium here sa reactant, pila iyang oxidation state?
4.
+4. Chlorine is
-1.
-1. Okay, pero wala na lang gibutangan diri og oxidation state si chlorine because chlorine is neither oxidized nor reduced. Diri -1 siya, pag abot diri -1 lang gihapon. So wala na lang napubutang oxidation state is in the uncombined state, so this is also 0. Magnesium in magnesium chloride is +2. Okay, so which one oxidizes and which one reduces? Isa may nag-reduce.
Ang
Chlorine.
titanium, ma'am.
Magnesium.
Si magnesium nag-reduce. Unsa kanito? Ang
Ti-
characteristic sa mag-reduce?
Titanium.
Mag-gain.
Mag-gain.
Nag-gain ba si magnesium? From
Wala.
0 to +2.
Yes, ma'am.
Nag-gain ba siya? From 0 to +2. Nag-gain ba?
Ay, nag-lose.
Wala, ma'am.
Nag-lose. Oh,
Nag-lose.
ihatag
Nag-lose
niya.
ako.
How many electrons does it lose?
2.
2
So,
electrons. After losing 2 electrons, magnesium becomes +2. So meaning magnesium
oxidizes.
oxidizes. Okay, how about titanium? From positive 4 nahimong 0. Titanium accepts or gains how many electrons? Pila ka electrons iyang gigain?
4.
4. So after gaining 4 electrons, imbis kay milabaw iyang protons, accept siya 4 electrons, so naparisan ning upat ka protons. So its charge becomes, or its oxidation becomes 0. Okay? Then we also have this halogen displacement, no? Same ra gihapon ang concept. One is reduced, the other one is oxidized. But this type of displacement is halogen because bromine molecule is a halogen. Okay, so same ra gihapon ang concept. Okay. So this is the activity series for metals. The metals are arranged according to their ability to displace hydrogen from an acid or water. Okay, so, di ba, I know you are familiar with this already. So, kung kinsa ang nasa ibabaw, mo ay maka-displace kinsa ay naa sa ubos niya. No? Like, for example, the reaction between calcium and water. Ang sa mandapit si calcium, ani? Calcium.
Mayroon ka.
here.
Sila rin nagtela sa school.
Okay.
Siya.
Hydrogen, asa si hydrogen? Hydrogen is
Adili ba
here.
siya sa school? Wala
So-
man. Kanang nag-ask lang siya, pwede ba makairam? Ano ko, wala mo siya.
Okay, Ma'am Jazzle.
Siya to.
Hello, Ma'am Jazzle. Thank you. Okay. So since calcium is more active than hydrogen, kay calcium is naa siya sa ibabaw, so it can displace hydrogen. So this reaction is possible. But in the case of lead that reacts with water, asa man dapit si lead? Oh, wait. Nara si lead, no? Naman siya ibabaw sa water. Ibabaw sa hydrogen. So, pwede na siya makadisplace ng hydrogen nga nung i-X ko man. Okay. So, dili na siya kuan dapat kay it can displace hydrogen.
Bitaw
No?
ma'am, kay higher biya ang charge
Oo.
ng 2-up lead sa hydrogen.
Yes.
Supposed
Oo.
to be ma-displace siya.
So, dili na siya X, sorry. Nasa UP. Sige. So, you know this already, no? Okay. Now, for halogens, nagipon tayo activity series for halogens. Fluorine is more active than chlorine, which means that fluorine can displace chlorine. Chlorine can displace bromine. Bromine can displace iodine. Fluorine can displace chlorine, bromine, and iodine. But iodine cannot displace all of this. No? Okay. Mas active maning niya sila. Okay. So like here, chlorine reacts with potassium bromide. So this reaction is possible. No, there is a reaction. Okay, chlorine is more active than bromine. Okay, but in the case of the reaction of iodine and potassium bromide, this reaction is not possible. As you can see in the series, bromine is more active than iodine. Okay. Then we also have the disproportionation reaction. Okay. Element here is simultaneously oxidized and reduced. Is it possible na isa ka element, oxidation and reduction pwede mo-occur sa iya? It's possible, no? And that is what we call disproportionation reaction. Like for example, chlorine molecule reacts with hydroxide ion. Okay, kung atong tan-awon, chlorine here is 0. Okay, then oxygen here, okay, wala na lang ni siya butangi og oxidation number kay kuan. It's neither oxidized nor reduced. So, wait, giuna lang pakita nako si chlorine di ay. So from here, from being 0 sa reactant side, pag abot sa product, kini siya nga chlorine, this is positive 1, di ba? Is-solve bilang yung oxidation number ni chlorine, it is positive 1. Okay? Pero chlorine diri is negative 1. Okay? So, wait. Ano ma-block siya? End of slide lagi. Budget lang ha. Hmm. Uy. Nag-end naman din. Di mo ako na-open. Okay. So, kung atong tanawa, from being 0 to positive 1. So, what does it mean? It means that this chlorine here gives
Oxidizes.
yes, it gives one electron. That's why it oxidizes, no? Pag abot aning isa ko compound nga na form, ang kini nga ion, ani nga compound, ang chlorine nahimong -1. Sa ato pa it gains one electron. No? It gains one electron. So see, the same element, but it oxidizes and it reduces simultaneously. Okay, so we call this type of reaction as disproportionation reaction. Do you understand?
Yes,
po.
ma'am.
Yes
Okay.
po.
Sige. Now, I'll open my other one. Wait lang. So, no questions regarding reduction or redox reaction? So, if there are no questions, let's proceed. Ako sa ni stop share ha. Kay lahi nga slide ako napakita. Pero sige lang, the same naman gihapon. Nalay uban nga wala na ako na-appeal. Okay. So we have here, classify the following redox reactions and indicate changes in the oxidation numbers of the elements. So what type of redox reaction is letter A?
Ma'am, you have no presentation yet.
Ay, sorry.
Have not presented it yet.
Sorry, I'm sorry. Sige. Letter A. What type rather of redox reaction is letter A?
Composition reaction, ma'am.
What type of redox reaction?
Decomposition. Decomposition.
Reaction. Di ba nato combination, decomposition, displacement, and disproportionation reaction. Okay. So letter A is decomposition reaction. How about letter B?
Combination.
Combination.
Obviously, it's combination. Ang letter A pud obvious kayo, it's decomposition. Letter C, it is
Metal
Displacement.
displacement.
okay, it's metal displacement, not to be more specific. And how about letter D?
Oxidation.
Does it oxidizes? No, oxidation ba? Nag-react ba siyang oxygen?
Hydrogen displacement, ma'am.
Disproportion.
Why did you say it's disproportion?
For NO2, I guess you have HN nitrite and nitric acid, and the other one is nitrous. So you don't have
Pila man
different.
si-
You have
Okay, what is the oxidation number of nitrogen here?
for
This is
NO2.
NO2, by the way.
Oh yeah, that's NO2. That's 2 plus 4 plus po.
Okay, correct. This is +4.
Yes
No?
po.
Oxygen here is -2. Hydrogen
Okay.
here is +1.
Positive 1 po.
Oxygen is -2.
Yes po.
Okay, here, oxygen is -2.
Oh, yeah.
Then,
Nitrogen is
hydrogen
3
is
plus po.
+1. So, pila man si
Yes po.
nitrogen dira?
3 plus po.
+3, correct.
3.
Okay. Here, this is -2, +1. So, pila man si nitrogen, ani?
Positive 5.
Positive 5 po.
Okay,
Si
it's
nitrogen po.
+5.
Yes po.
Okay, correct. Now, tanawa si nitrogen. Oxygen, sorry. Oxygen here is -2, -2, -2, -2. So it's neither reduced nor oxidized. Hydrogen also is +1, +1, +1. So pareha sila ni oxygen. So how about nitrogen? From being +2, pag abot diri nahimo siyang +3. Then
And it's
+2
oxidized.
to +5. Bata masayop? Wait, ha? +3, +5. Oh, so from +2 to
Positive 4 ang
+3,
nitrogen.
meaning nag-lose or it gives off
+4 ang nitrogen sa ano ma'am? Sa reactant. And then down to +3.
ano? Wait, +2 ang akong gisulat, sorry. This is
+4.
+4. Oo, correct. This is +4. No? +4 ni siya, then oxygen is -2. So, +4 o +3, meaning, nag-gain ba siya or
Gain
nag-lose?
electron.
Nag-gain siya o pila ka electron?
1.
Okay, nag-gain siya o 1 electron. No? Then, from +4 to +5.
Loss
One
of
E.
1 electron.
Okay. Nag-lose og 1 electron. So, gives 1 electron. So, nitrogen is oxidized and at the same time reduced. So, this is disproportionation reaction. Okay. Sige, this one. Classify the following reactions kung ako nang natuplok noon. Sige na lang. This is precipitation reaction. This is acid-base reaction. This is the acid, then the base, ammonia base. Then this is redox reaction. This is also redox reaction. Okay, now let's go to, so no questions regarding redox reaction, including the types. Lay pangutana. Okay, if there are no questions, let's go to solution reaction, solution stoichiometry. So it is the concentration of a solution is the amount of solute present in a given quantity of solvent or solute, no? Mostly, the concentration is expressed using molarity, in which molarity is equal to number of moles of solute divided by volume of the solution in liter. Okay, so molarity is designated by capital letter M. Okay, for example, what mass of potassium iodide is required to make 500 ml of a 2.80 molar potassium iodide solution? No? What mass of potassium iodide is required? Pila ko nung mass? Nabay mass diri? Wala. No? But then, we can calculate we can solve for the moles of potassium iodide using this formula. We can derive the formula in solving for moles, no? That is molarity equals N over V. So to solve for N, we have N equals M times V. Okay, so wait lang, ha? Okay, so the volume of potassium iodide solution is given, which is 500 ml. Then we are going to multiply that with the molarity. Okay, from the formula, number of moles equals molarity times volume, no? So makuha na to ang number of moles. So after getting the number of moles of potassium iodide, i-multiply na to sa ihang molar mass. Then, kung pila ang molar mass of potassium iodide, multiply na to sa number of moles. So then it will give us, the final answer would be the mass of potassium iodide, which is required to make 500 ml of 2.80 molar potassium iodide solution. Okay. So starting with the volume of potassium iodide solution, which is 500 ml, and 500, since molarity is expressed in liter, no? That's moles per liter of solution. So we need to convert milliliter to liter by multiplying this conversion factor to the given volume. Okay, so we can cancel the unit milliliter and then multiply it to the molarity of the potassium iodide solution, which is 2.80 molar. 2.80 molar is the same as 2.80 moles per liter of solution. So here we can also cancel out the unit liter. Then sa nanatay mole, then after getting the number of moles of potassium iodide, let us multiply it to the molar mass of potassium iodide. So pila man ang molar mass ni potassium? That's 39.99 ba to? Pila ay periodic table. Naman to akong periodic table. Okay, anyway, ako na nang na-solve daan. It is 166 grams, no? 166 grams of potassium iodide per mole of potassium iodide. So cancel the units, then do the calculation. So it gives us 232 grams of potassium iodide. So 232 grams of potassium iodide is required for us to make 500 ml of 2.80 molar potassium iodide solution. Okay. Okay, how many grams of potassium dichromate are required to prepare 250 ml solution whose concentration is 2.16? So mass gihapon ni potassium dichromate, no? So pila kuno ang mass ni potassium dichromate ang kailangan for us to prepare 250 ml of the solution with a concentration of 2.16 moles per liter. So again, starting with solving with the moles of potassium dichromate. So moles of potassium dichromate, kini lang atong gamiton. So 2.16 moles per liter of potassium dichromate. This is the molarity times the given volume, which is 250 ml. So we cannot cancel out if we're going to use ml. So wana gi-change siya into liter. So 250 ml is equal to 0.250 liter. So this time we can cancel out the unit liter. So by doing the computation, it gives us 0.540 mole of potassium dichromate. Then after that, let us multiply this to the molar mass of potassium dichromate para ma-cancel out ang mole. Then what will be left is the unit gram. And 1 mole of potassium dichromate is equal to 294.2 grams, which this is our molar mass, no? So 0.540 mole of potassium dichromate times its molar mass. So the mass required to prepare 250 ml of the solution is 159 grams of potassium dichromate. Okay. Okay, another. In a biochemical assay, a chemist needs to add 3.81 grams of glucose to a reaction mixture. Calculate the volume in milliliters of a 2.53 molar glucose solution she should use for the addition. So, unsay atong ipa-compute ani? Volume. No? Volume of the 2.53 molar glucose. Okay. So, starting with the 3.81 grams of glucose, for us to calculate, we need to calculate the number of moles, no, of the glucose. So 3.81 grams of glucose, this is given, no, the given mass of glucose, times the molar mass of glucose, which is 180.2. So it gives us 114 times 10 raised to the power of -2 mole of glucose. So nanatay na calculate ng moles of glucose. Ang ipa-calculate mong god is the volume. Okay? So here, we can calculate the volume of the solution that contains 2.114 times 10 raised to the power of -2 mole of the solute. So volume is computed, diba, from the formula, molarity equals number of moles over volume. From that formula, we can derive the formula of volume, which is equal to number of moles over molarity. So we have computed already the number of moles, which is 2.14 times 10 to the -2 mole of glucose divided by its molarity. That's 2.53 moles per liter solution. So cancel out the unit mole. So we have mole per liter. Okay. So since the question is asking for the volume in milliliters, so we're going to multiply this conversion factor, 1000 ml over 1 liter, and that gives us 8.36 ml of the solution. Okay. Do you have questions or clarifications? Okay. So to prepare a solution of known molarity, okay, we have these steps, no? A known amount of a solid solute is transferred into a volumetric flask. Okay, then water is added through a funnel. Now, do not fill it yet, no? Bisag taman lang sa dinha, no? So that you can swirl properly. For you to swirl properly the water, okay? Because by swirling, it will help you in dissolving the solid substance here, no? So you cannot swirl, you can hardly swirl the water if it is already, there is a neck or dira sa kaning murag neck sa volumetric flask, no? So in preparing a solution, of course, you need to determine the mass of your solute, no? Then you put it inside the volumetric flask, and then you add water. Let's say this volumetric flask is 250 ml, no? Bata nato this is pag abot aning mark, this is 250 ml. So before filling this up to this mark with water, dapat imong water sa taman sa dinha so that you can swirl the liquid properly, no? Pwede pa nimo ma-swirl, and by swirling, it will help you dissolve easily the solid. Okay, so the solid once the solid is dissolved after swirling, just swirl gently. Do not do like that. Kay manglagsik na imuhang kuan. Imuhang solution diha sa sulod, no? So just swirl. Iana lang, swirling. Okay. Then, if you notice that the solid substance here is already dissolved, that's the time for you to fill more water, but only up to this mark, no? The lower meniscus of the water should be up to this mark, okay? And that gives you, if this volumetric flask is 250 ml, meaning, maabot ka din ha nga level, meaning your solution is already 250 ml. Okay. Okay, now let's go to dilution. This is the procedure for preparing a less concentrated solution from a more concentrated solution. Now, solutions from stock room, no, are usually concentrated, no, mga concentrated kaay na sila. So we need to dilute them first. We need to dilute them first before siya gamiton for our experiments, no? So to dilute, okay, to dilute a more concentrated solution, just add water or just add solvent, no? Depende sa solvent na imong gamiton. And by adding solvent, it will increase the volume of your solution, but the moles, no, the number of moles of the solute remains the same. So moles of solute before dilution is just the same as the number of moles after dilution. Okay, so what changes here is the volume of the solution because we are adding solvent. If your solvent is water, water amang pud imong gidugang. Wa man ka nagdugang og solute. So only the volume changes, but only the volume of the solution changes, but the number of moles of the solute remains the same. Okay, so in the previous slides, you have learned that number of moles is equal to the product of concentration and volume, no? So if moles of solute before dilution is equal to moles of solute after dilution, it is also the same when we say the product of the concentration and volume, the product of the initial concentration and initial volume is equal to the product of the final concentration and volume, no? Okay, the product of the concentration and volume is equal to moles, no? So this is the number of moles before dilution, number of moles after dilution. So they are equal because we are not adding solute in dilution, but we are adding solvent. So only the volume changes, but the number of moles remains the same. Okay, for example, how would you prepare 60 ml of 0.200 molar nitric acid from a stock solution? So the stock solution, as you can see, is very concentrated. No, pila yung concentration? 4 moles per liter. No, this is the concentration of the nitric acid from the stock solutions or from a stock solution, 4 moles per liter. And then we are asked, how are we going to prepare 60 ml with a 60 ml of nitric acid with this concentration 0.200 molar? Okay, so you have learned that moles of solute before dilution is equal to moles of solute after dilution. Okay, so our initial concentration is 4 moles per liter, but we do not know the volume. No, we do not know the volume. Then our final concentration, our desired concentration, which is our final concentration, is 0.2. No, 0.200 molar. From 4, magkuha lang ta din ha og gamay, i-dilute nato para naatay 0.2 or 0.200 molar. And our final concentration is 60 ml in liter, we have 0.06 liter. No? Okay. So we need to determine first our initial volume of the nitric acid. No? We do not know kung pila man day ang volume sa atong nitric acid. So we need to determine first the initial volume of our nitric acid. So initial volume, from this formula, we can derive the formula of our initial volume, which is the product of the final concentration and final volume divided by the initial concentration. Then substitute the values. Our final volume, final concentration is 0.2 moles per liter times the volume of the final volume, which is 0.06 divided by the initial concentration, which is 4.00 moles per liter. No? So, makancel ang unit ni 0.2 o ni 4. Okay? So, that gives us 0.003 liter, or this is equal to 3 milliliter. Okay, so the question man good is, how would you prepare? How would you prepare 60 ml of 0.200? Now, knowing that the volume of the stock solution, the volume of the 4.00 molar nitric acid is 3 ml. So para makaprepare ta aning 60 ml of the solution with this concentration, we will just add, this is the initial volume man. So 3 ml of the acid plus, para mahimong 60, magdugan tag water, which is 57 ml, to have a 60 ml of the solution. Okay? So it will give us 60 ml of the solution. No? 3 ml lang man ang available aning stock solution. So para makaabot ta o makakuha ta aning desired quantity, desired concentration, and desired volume of the stock solution, we need to add 57 ml of water for us to come up with 60 ml of the solution. Okay? Now describe how would you prepare. Wait. Erase. Describe how you would prepare 5 times 10 raised power of 2 ml, meaning this is 500 ml of a 1.75 molar sulfuric acid solution, starting with the stock solution, 6.81 molar stock solution of sulfuric acid. So, para may bawaan na to, no? We need to know first how many ml of the stock solution. Pila man din ni ka ml sa stock solution of this concentrated solution. Para by knowing the volume of the stock solution, we will be able to determine how much of the water, how much of the solvent will be added to come up with the 500 ml solution. Okay? So again, unahon na to solve ang volume of the stock solution. Okay? So volume of the stock solution, just substitute the values, no? Atong initial concentration times initial volume equals final concentration times final volume. Just substitute the values and then you will be able to solve with the initial volume, and that gives us 102 ml. So 102 ml of the stock solution with this concentration 8.61 moles per liter. So the question now is, describe how would you prepare 500 ml of 1.75 molar sulfuric acid solution. So knowing the initial volume, knowing the volume of the stock solution, we will be able to know how much of the water, how much of the solvent that should be added to this stock solution in order to prepare 500 ml. So to answer that question, just dilute, no? We must dilute 102 ml of the 8.61 molar sulfuric acid solution with sufficient water to give a final volume of 500 ml in a 500 ml volumetric flask to obtain the desired concentration, which is 1.75 moles per liter. Okay. Hello.
Yes,
You have
ma'am.
questions regarding dilution? No? So, ingon ini nga mga problems, dapat we should know first the initial volume of the stock solution. Ay ta makabalo kung pila atong iduga nga water. Okay? Sige. Now let's go to gravimetric analysis. Sa na ako ang time, ha? Basig maulahin na po dito. Okay, dapat na enough time. So, gravimetric analysis is an analytical technique based on the measurement of mass. It involves the formation, isolation, and mass determination of a precipitate. It is applied to ionic compounds, and it is a highly accurate technique because the mass of a sample can be measured accurately. Okay, it is applicable only to reactions that go to completion or have nearly 100% yield. So again, gravimetric analysis is an analytical technique based on the measurement of mass. Okay. So to undergo gravimetric analysis, of course, we need to dissolve an unknown substance in water, no, to make a solution. And then react the unknown solution, or to react the solution containing the unknown substance with the solution containing the known substance to form a precipitate. So for example, kini nga solution mo ni ang imuhang solution containing the unknown substance. Mo dahil ni ang imuhang solution containing the known substance. Okay? Then you react this, you allow them to react by mixing them together para maka-form siya og precipitate. So in this case, this is the precipitate that is formed after adding this solution into the solution in the beaker. Okay? And then, so naka-form na kag-precipitate. After that, you need to filter to remove the precipitate from the solution and let it dry. Okay? Then, weigh the precipitate. No? After drying, atong timbangon ang precipitate, and then use chemical formula and mass of precipitate to determine amount of the unknown ion. Okay, so for example, if we have the aqueous silver nitrate reacts with aqueous sodium chloride to form aqueous sodium nitrate and silver chloride. So silver chloride here is our precipitate. So in this case, after canceling our spectator ions, our net ionic equation is this one, no? Aqueous silver ion reacts with aqueous chloride ion to form silver chloride, which is solid. So silver chloride here in this reaction is our precipitate. No? So if the precipitate is formed like silver chloride in this reaction, we need to filter this silver chloride, let it dry, and then weigh it. Okay. So to determine the percent by mass of chlorine, take note that our original our original substances, no? Our reacting substances are the silver nitrate solution and sodium chloride solution. Okay. So to determine the percent by mass of chlorine in sodium chloride, now in gravimetric analysis, we need to determine the percent by mass of chlorine, like in this reaction, we need to determine the percent by mass of chlorine in the given sample of sodium chloride. But we can do it if we know the percent composition of chlorine in our precipitate. Did you get me? Okay. Again, we will be able to determine the percent by mass of chlorine from our original compound, original sample, if we know the percent by mass of chlorine in the precipitate. Okay. So to determine the percent by mass of chlorine in sodium chloride, we need to weigh out a sample of sodium chloride and dissolve it in water. Then add enough silver nitrate solution to the sodium chloride solution to cause the precipitation of all the chloride ions present in solution of silver chloride. Then the silver chloride precipitate is separated from the solution by filtration, dried, and weighed. And from the measured mass of silver chloride, we can calculate the mass of chlorine using the percent by mass of chlorine in silver chloride. Because this same amount of chlorine was present in the original sample of sodium chloride, from here, we can calculate the percent by mass of chlorine in sodium chloride. No? So for example, 0.5662 gram sample of an ionic compound containing chloride ion. So supposing wala ta kabalo unsa na nga ionic compound, no? Basta kabalo lang ta nga na siya chloride ion. Okay. And an unknown metal is dissolved, no? Okay, ionic compound containing chloride ions and an unknown metal. Pero wala ta kabalo unsa na siya nga metal, mana unknown, is dissolved in water and treated with an excess of silver nitrate. If 1.0882 grams of silver chloride precipitate forms, what is the percent by mass of chlorine in the original compound? Okay. Can you imagine unsa ang naa sa compound? Diba, the original compound in which we are aware that the compound is an ionic compound which contains chloride ion and an unknown metal. Okay, unknown metal. And the mass of the ionic compound is 0.5662 gram. Then we are asked to determine the percent by mass of chlorine nga naa diri sa original compound. No, naa diri sa original compound. So we can do it by knowing first the mass of the precipitate that will be formed when silver nitrate will be added into that ionic compound. Then from there, we can calculate the percent by mass of chlorine which is present here in the original compound. No? Okay. So percent of chlorine is equal to mass of chlorine divided by the mass of the ionic compound, no, which is our original compound. And that mass is equal to 0.5662 gram times 100. So our answer would give us the percent by mass of chlorine. Okay. Now, wait. But at this level, we cannot solve yet for the percent by mass of chlorine in the original compound because we do not know the mass of chlorine, no? Wala pa kabalo pila day ang mass of chlorine. Ay nata makasolve sa percent by mass of chlorine if we know the mass of chlorine from the precipitate. Okay? Kay ang chlorine nga nasa precipitate is coming from the chlorine of the original compound. Okay? So we need to determine first the mass of chlorine found in the precipitate, no? So di ba? Pila ang mass sa precipitate? The mass of the precipitate is 1.0882 grams. No, this is the mass obtained of the precipitate silver chloride. So, we know that the molar mass, no, the molar mass of an element is equal to its atomic mass. The atomic mass of chlorine is 35.45. The molar mass of silver chloride is 143.4. So, giunsa man pag-obtain aning 143.4, this is the mass of chlorine plus the mass of silver. Okay, so it gives us 143.4. So, to determine the percentage by mass of chlorine in this precipitate, mo man yung atong precipitate, silver chloride. So, percent by mass of chlorine in silver chloride is, okay, di ba? 35.45 grams of chlorine divided by the molar mass of silver chloride, which is the precipitate, then times 100. Okay, times 100. So 35.45 divided by 143.4 times 100, that gives us 24.72%. Ang bot pa sa bot, in silver chloride, 24.72% of it is chlorine. Do you get me? Sabtan to ninyo?
Yes po, ma'am.
Yes, ma'am.
Okay. So, di ba silver chloride is our precipitate? Now, we need to determine first the percent by mass of chlorine present in our precipitate. And to determine the percent by mass of chlorine in the precipitate silver chloride, we need to divide the molar mass of chlorine by the molar mass of silver chloride, then times 100, so that gives us 24.72%. So in silver chloride, no, in silver chloride, 24.72% of it is chlorine. Sa ato pa ang percent by mass of silver nga naa sa silver chloride is about 75.28%. Yeah, tama ba? 75.28% is silver and 24.72% is chlorine. Okay. Now, so we know we are given with the mass of the precipitate. Gihatagan tag mass sa precipitate, which is 1.0882. So from here, we can solve for the mass of chlorine, knowing the mass of the precipitate, the mass of silver chloride, and knowing also the percent composition by mass of chlorine present in silver chloride. Diba? Pila gani ito ka percent ang chlorine nga naa sa silver chloride? It is 24.72%, no? So para makuha nato pila ang mass of chlorine na aning mass of silver chloride, just multiply 24.72% and 1.0882. So of course, dili na to idiretso multiply 24.72. We have to express it in decimal form. So that's 0.2472 times 1.0882 gram. And that gives us 0.2690 gram. So this amount is the 24.72% of 1.0882 grams. Do you understand? Sabtan ko ninyo?
Yes po.
Oh.
Yes po,
Kini
ma'am.
siya, balikan na ko, kini siya nga mass of chlorine. This is the 24.72% of the available mass of the precipitate, which is 1.0882. Okay? Now remember, ang gipangutana sa ato is, what is the percent by mass of chlorine in the original compound? Okay? So pila ang mass sa original compound? Di ba the mass of the original compound is 0.5662? Okay? So, and remember that the chlorine present in the precipitate silver chloride is the same, or is the chlorine, the amount of chlorine pod nga naa dito sa original compound. So if the mass of chlorine in the precipitate is 0.2690, we can use that amount for us to determine the percent of chlorine nga naa sa original compound, no? So the mass of chlorine nga naa sa silver chloride, which is 0.2690, divided by the mass of the original compound, that is 0.5662 gram times 100. So percent of chlorine present in the original compound is about 47.51%. Do you understand? Am I understood? Hello?
Yes po,
Basin
ma'am.
nakatulog na din.
Yes po, ma'am.
Nakatulog na. Sige. So I hope you understood, no? Sige, walay pangutana. Yan na lang yung testingan of solve ng kuan. No? Now let's go to titrations. So in a titration solution, a solution of accurately known concentration is added gradually to another solution. Sorry, nadubli na kung added, of unknown concentration, no? A solution of accurately known concentration is added gradually to another solution of unknown concentration until the chemical reaction between two solutions is complete. Okay. Usually, the solution with accurately known concentration is placed in the burette, and the solution with the unknown concentration is placed in the Erlenmeyer flask. No? So the solution in the burette is what we call the titrant, and the solution in the Erlenmeyer flask is what we call the analyte. Okay. So when can we say that the chemical reaction between the two solutions is complete? Now, if it is complete, if the equivalence point has been reached, no? The equivalence point of the reaction has been reached. So, ons may buot pasabot kung naa na sa equivalence point. It means that the number of moles, the moles of the known concentration is equal to the moles of the unknown concentration. Okay. In titration reaction, we need to use indicators, no? An indicator. Now, klase-klase ang mga indicators. We have the methyl orange, we have the bromthymol blue, we also have the phenolphthalein, no? The most common one is the phenolphthalein solution. So an indicator is a substance that changes color at equivalence point or near equivalence point. Like for example, if we're going to use a phenolphthalein solution, we're going to add siguro about 3 drops of the phenolphthalein solution into, let's say, the substance or the solution in our Erlenmeyer flask is an acid. If a phenolphthalein solution, if added to an acid, it is colorless, no? Pero kung if the phenolphthalein solution is in a basic solution, it will change its color into something like purple or fuchsia pink, no? So ma-change iyang color kung basic na ang solution. Okay? So here, this is the setup for titration. So the solution here, this is the Erlenmeyer flask, this is the burette, no? Then the phenolphthalein or the indicator like phenolphthalein is added to this solution. Okay? So kung kini nga solution is, let us say, kung kini siya is an acidic solution, kunya diri gibutangan og phenolphthalein, while wala pa gidungagan og base, this solution remains colorless, no? The phenolphthalein present in this solution remains colorless. Pero kung if the base in the burette is gradually added, there would be an increase in the concentration of base nga naa na dayon diri, no? Kay gidugangan man ni siya base. So there would be an increase in the concentration of the basic substance inside the Erlenmeyer flask, no? Kung maabot na gani, if the reaction is complete, the indicator added here will change its color, no? Okay. Okay, so the indicator changes its color. Okay, so for example, what volume of a 1.420 molar sodium hydroxide solution is required to titrate 25 ml of a 4.50 molar sulfuric acid solution? Okay, so the concentration of the base, pwede inyo sa aning i-screenshot.
Yes.
Wala akong internet sa akong tablet. Ambot lang. Ang akong tang gusto magsulat-sulat ko pero wala man. Sige, diri na lang din na lang. Okay na lang. Ayan na lang ninyo anyway, naman po kayo gisulat daan diri nga solution. So the sodium hydroxide solution, the molarity of the sodium hydroxide solution is 1.420 molar, no? This is the solution in our burette. And in our Erlenmeyer flask, there is another solution, a sulfuric acid solution, about 25 ml, which is 4.50 molar. Okay. Ang ipangutana sa ato is, what is the volume of our sodium hydroxide solution that is required to titrate, no? Required to titrate this given amount of the acid. Okay. So the first thing that we're going to do is to write first the reaction, no? So when sulfuric acid reacts with sodium hydroxide, it will produce water and sodium sulfate, diba? And then, of course, we need to balance. So this is already a balanced equation. So this means that 1 mole of sulfuric acid reacts with 2 moles of sodium hydroxide to produce 2 moles of water and 1 mole of sulfuric acid. Do you understand? We need to have a balanced equation for us to use the correct stoichiometric ratio, no? So given the volume of the acid, which is 25 ml, we can convert this into mole by multiplying this to the molarity of sulfuric acid. Kung naa tay molarity sa sulfuric acid, i-multiply na pud nato sa stoichiometric ratio between the acid and the base. So mo man yung atong acid, sulfuric acid, then this is our base. The stoichiometric ratio between these two is 1 mole of sulfuric acid is to 2 moles of sodium hydroxide, no? Dayon, kung naa tay mole of the sodium hydroxide, let us multiply it to the molarity, the given molarity of sodium hydroxide. No? Makancel dahil na to ang volume, makancel na to ang number of moles, ay na dahil magawas ang volume. Okay? So, okay. So, starting with the given volume of the sulfuric acid solution times, pila yung molarity? The molarity is 4.50 moles or moles per liter of solution, and 1 liter is equal to 1000 ml. We converted this to ml because the given volume is expressed in ml, no? So makancel na to ang ml ani, then the unit left is mole. So mole of sulfuric acid ang mabilin, and we are asked to compute for the volume of the base. So for us to kanang para ta makaabot dire, for us to arrive with the moles of sodium hydroxide, i-multiply sa nato sa stoichiometric ratio between the acid and the base. Asa nato makita ang stoichiometric ratio? That can be obtained from the balanced equation. The balanced equation tells us that 1 mole of the acid, sulfuric acid, reacts with 2 moles of sodium hydroxide. Okay? So, kana nga stoichiometric ratio, 1:2, mo na atong gamiton to multiply here. Okay. So, ang numerator is 2 moles of sodium hydroxide. Ang atong denominator is 1 mole of sulfuric acid. Because our denominator is the mole of the acid because we want to cancel out the mole of the acid so that ang mabilin is moles of sodium hydroxide. And then, after having the moles of sodium hydroxide, para makaabot ta sa volume of sodium hydroxide, we need to multiply this with the given molarity, given concentration of sodium hydroxide. The given concentration is 1.420 molar, and that is also equal to 1.420 moles per liter of sodium hydroxide solution. Okay, so that is times 1000 ml over 1.420 mole sodium hydroxide. Okay, nga nung 1000 ml ang atong gigamit, why not liter? Okay, pwede ra gyapon atong i-convert later unsang atong answer. So cancel sa nato ang ml. Okay, cancel mole of the acid and then mole of sodium hydroxide. So ang nabilin is the volume of the solution. By using your calculator, no, we can get 158 ml, or this is equal to 0.158 liter. Okay. So in order to titrate 25 ml of 450 molar sulfuric acid, we need to have 158 ml of 1.420 molar sodium hydroxide solution. Okay. Hello.
Yes, ma'am.
Do you understand?
Yes, ma'am.
Okay. Sige, kasabot man ka mo, no? Padayon lang sa ako. Okay, now let's go to redox titration. We have learned already about titrations kay na atong gi-discuss a while ago, no? So, titrations can be used in the analysis of acid-base reactions, just like the example given in the previous slide. And like here, the reaction of sulfuric acid and sodium hydroxide to produce water and sodium sulfate. And it can also, titration reaction or titration can also be used in the analysis of a redox reaction. Okay, so like for example, 5 moles of iron 2 plus 1 mole of permanganate ion plus 8 moles of hydrogen produce 1 mole of manganese 2, 5 moles of iron 3, and 4 moles of water. Okay. So, unsa di ang redox titration? So, in redox titration, we can titrate an oxidizing agent against a reducing agent. No? That is by adding a solution containing an oxidizing agent to a solution containing a reducing agent. And then the equivalence point is reached when the reducing agent is completely oxidized by the oxidizing agent. Normally, it requires an indicator, of course, kay titration man ni, that clearly changes color. At the equivalence point or near the equivalence point, a sharp change in the indicator's color will occur as it changes from one form to the other. And there are 2 common oxidizing agents that can be used. We can have the potassium permanganate and potassium dichromate. Okay, so for example, let's try this problem, no? A 16.42 ml volume of 0.1327 molar potassium permanganate solution is needed to oxidize 25 ml of, this is iron 2 sulfate solution in an acidic medium. What is the concentration of the iron 2 sulfate solution in molarity? So this is the net ionic equation na, no? Given na ang net ionic equation, and this is already balanced. Okay? So unsa to ang gipangutana? What is the concentration of iron 2 sulfate solution? No? Concentration in molarity. Knowing the volume and concentration of potassium permanganate solution. So this potassium permanganate solution is needed to oxidize the iron 2 sulfate, and the available mass of the iron 2 sulfate is 25 ml. Okay, so unsa man kay atong unahon? What are we going to do first? So given ang volume and molarity of potassium permanganate, first is to compute for the number of moles of the potassium permanganate solution. Diba? Unahan na to compute ang moles of the potassium permanganate solution. After solving the number of moles of potassium permanganate solution, multiply the number of moles of potassium permanganate solution, multiply it with the stoichiometric ratio between the potassium permanganate and iron 2 sulfate. Okay? Kaya ang ato ang desired quantity is the concentration of iron sulfate. Ang atong gisolve lang una is the mole of potassium permanganate. So para mo connect ta dito sa, maabot ta dito sa iron 2 sulfate, we need to multiply the number of moles of potassium permanganate with the stoichiometric ratio between the potassium permanganate and iron 2 sulfate. And where can we obtain that? We can obtain their ratio from the balanced equation. Do you understand? Sabtan ko ninyo?
Yes, ma'am.
So about the others, ang uban naghagok naman siguro ning uban, no? Hello.
Yes,
Wala
ma'am.
pa man.
Or nangaon na baka ning uban ani. Sige. Padayon lang gyapon po. Hindi mo kasabot sa ako karon. You can read the man, the PDF na didto na tanan. Sige. Anyway. So, balikon na ako, no? We need to compute first the number of moles of our potassium permanganate. Pa-compute nato ang number of moles, di ba? Molarity is equal to N over V. O nya, given man ang N. Sige, ako na lang gamiton ni ako. Ang pwede naman siguro ni na ako ma-share. Kadjat lang na. Ay, wala. Okay. So we need to calculate first. Can you hear me?
Yes, ma'am.
Yes po.
Sige. We need to calculate first the number of moles of potassium permanganate. Okay. So, di ba? Given the molarity and volume, so di ba? Molarity is equal to number of moles over volume. We are looking for the number of moles, so ato na i-cross multiply. No? So that is molarity of potassium permanganate times the volume of potassium permanganate. Okay, so pilang molarity? That is 0.1327. This is mole per liter. Okay, times the volume is 16.42 ml. So ato i-convert na si liter into milliliter. So 1 liter is 1,000 ml. Okay, so cancel ml. And this is equal to, pila man ni? 0.1327 times 16.42, that gives us 2.17.
17.
Okay. Pila ka significant figures ang atong given? Kini, pila man ka significant figures? This is 4. So, dapat atong answer is 4 significant figures, no? Times 10 raised to the power of negative 3 mole of potassium permanganate. Okay, so nanatay mole of potassium permanganate. Then, after having the number of moles of potassium permanganate, para maabot ta sa iron 2 sulfate, kay iron 2 sulfate ang gipangita. So, para maabot ta sa iron 2 sulfate, i-multiply nato ni siya sa number as a stoichiometric ratio. And we can find the stoichiometric ratio from the balanced equation, no? So, that is 2.179 times 10 raised to the power of negative 3 mole of potassium permanganate. And from the balanced equation, it tells us that there is it tells us that there is 1 mole of potassium permanganate to react with 5 moles of iron 2 sulfate, no? So cancel. Ang nabilin is the number of moles of iron 2 sulfate. Ang gipangita kay kuan man, sa gipangita concentration ni iron sulfate. So for us to come up with the concentration of iron sulfate, let us multiply it to natin multiply. Given ba ang volume kay moles per liter?
Given po.
Okay. So times pila man ni para naatay kuan let us have first the number of moles of iron 2 sulfate. Pila man ang number of moles of iron 2 sulfate? Multiply daw ni siya. 2.179 times 10 raised to the power of -3 times 5 moles. Pila?
0.01.
0.
Point
Or 1.090 times 10 raised to the power of negative 2. Okay, negative 2 mole of iron 2 sulfate. This is iron 2 sulfate. Okay. So, ato ang gusto is concentration. Di ba? Molarity is equal to number of moles of solute over volume of solution. So, molarity is equal to, that is 1.090 times 10 raised to the power of negative 2 mole of iron 2 sulfate over pila ka ml, ani? Ang ilang gusto? 25.00 ml. Now, ml man, yeah, dapat kung molarity, liter of solution. No? So, times liter of solution man. So, times 1,000 ml over 1 liter. Okay, so cancel. Sana na tayo mole per liter nga unit. So, what is the molarity now of our iron 2 sulfate?
0.4360 molar.
Okay, 0.4360 molar, no? Or this is moles per liter. Mole per liter of iron 2 sulfate. This is now the molarity of the 25 ml iron 2 sulfate. Okay. Hello.
Excuse po, ma'am. Ma'am, we still have a class,
Ala,
ma'am, sa 10.
Sorry, oo, thank you for reminding me. Nahuman na po akong chapter 1. Sige. So,
Ay, by the way, ma'am, can we
Yes.
have a copy of your PowerPoint presentation?
the kidding presentation, these are all coming from the PDF that I gave you. No? So, pwede na to ninyo kung anon, katong PDF na asa use step. Tanan nga akong sa
Ma'am,
sa
still,
presentation.
dili gyapon may ka-access, ma'am, sa
Same, ma'am. Wala pa may ka-access, ma'am.
Dili pa gyapon mo ka-access. Naghatag na ra ba kog mga exercises adto. Ala, Sir Ronnie, dili daw sila ka-access sa use step.
Wala kayo mong
nag-letter
subject,
na pod mi,
ma'am.
ma'am.
Nagsulat na sa daw sila. Ha? Ano sa may
Itaw na to sa
DTO? Sige lang, kay tawagan na mo ang DTO. Nag-email na mo?
Yes po, nag-email na po, ma'am.
Ma'am.
Sige. So, para maka-read mo in advance, ihatag na lang nako ang PDF dito sa, i-attach na ko sa, i-post na ko sa kuan, ato ang group chat, okay ra? Bisag,
Okay, ma'am.
ulahin na lang ninyo
Yes, ma'am.
answeran ang atong mga exercises, no? Dayon, maghatag ko mga questions para mag-solve mo sa Saturday, no? Yun, mo ay inyong buhaton, practice solving sa Saturday. Dayon, week after Saturday, week after next week, pag-test ta sa chapter 1. Okay? So this coming
Okay po.
Saturday, di sa ta mag-meet aron mag-solve sa amo aning mga exercises nga akong ihatag sa inyo, ha. No, kay di man ninyo, I know wa kay man nakasabot sa ako ang gi-discuss. Kay lahi man gyud kung inyong i-practice og solve. So, mo na inyong buhaton sa Saturday, mag-solve mo. Naghatag ko exercises for you to solve. Siguro i-submit ninyo by Monday next week. Okay, wait. Unya day ko maghatag sa exercises, sorry. Unya day ko maghatag sa exercises. Dayon. Sige, maulahin na ta, no? Kadyot lang, ha? Sa tanan ng kalendar. Kaya kung maulahi ta, basig dili na to ma-discuss tanan ni ato ang topics. Sa man, okay ra sa inyo, mag-solve sa mo karong Saturday? No, maghatag ko mga exercises.
Yes, ma'am.
Dayon, pagkasunod, ay hata mag-quiz. Long test. Unsa ta karon
Next
nga
week, ma'am.
Saturday? 24 man ta karon, no? So next
October 1 ang next.
Saturday, October 1. Di maghatag na lang ko sa exercises, i-post na ko. Kung di pa mo maka-access, ihatag na ko exercises sa Monday. Makaya ba ninyo? Mag-solve mo aning a week para pagka Monday, mag-discuss ta sa answers. Pagka Saturday sa October 1, mag-discuss ta sa answers. Ngayon pagka October 8, mag-test.
Okay po, ma'am.
Ana na lang, no?
Okay, ma'am.
So, again ha, this coming Monday, I'll make sure na may copy sa exercises na yun. Mag-discuss na sa answers. Of course, you have to submit your answer sa exercises. So that pagka Saturday next week, atong i-discuss ang answers, pagka October 8, mag-test dayon ta. No? So kadtong mag-submit be sure to submit your papers, your answers before October 1. Kay kung mag-submit mo after October 1, na dili na ako na i-check kay kita na mo i-discuss din akong answers ani October 1. No? So isag inyong i-submit inyong papers sa October 30 o September 30. Para October 1, discussion of the correct answers. Then October 8, we'll have our test.
Faith.
Yes.
We send it to your Gmail po, ma'am.
Unsa may i-send?
Ang answer, ma'am, because we cannot access pa man our step po, ma'am.
Oo, no. Sige, okay lang. Pero I hope you can access next week na. I-follow up mo po ni Sir Ronnie. You just tell me if you cannot access until by Tuesday. No, naman tayo group chat. Please inform me sa Tuesday if dili pa bagyapon ninyo ma-access. Kay sa Monday na matawagan ni Sir Ronnie ang DTO. Kay wala may office karon. Okay ra? Any
Okay po,
reaction?
Yes, ma'am. Ma'am Faith, thank you.
Okay. So, Tuesday, mag-expect ko nga mag-message mo sa atong group chat ha kung inyo bang na-access na ang U-step or not. Kay kung dili, ay na din ta mo decide. No, kay dili magud ko di ko ganahan nga dito mag-submit sa email kay usahay mga tabunan. Daghan kay kung mga kadawat ko kanay mga email sa matabunan siya basig di na ako ma-open. No, so mas maayo kung sa U-step gyud unta. You just inform me kung until Tuesday dili pa gihapon mo maka-access. Kay sa Monday pa namo pod matawagan ang U-step. Ang DTO, I mean. Okay, okay ra na sa inyo ha?
Yes po.
Okay, so thank you for listening. Sige na, kay mura og sorry ha. Gihurot na po na akong inyong oras. Sige, kasi masukod
Thank
na
you
to
po,
inyong
ma'am.
Sige,
Thank you,
okay,
ma'am.
bye-bye everyone.
Thank you, ma'am. Bye.